OpenAI just dropped something that nobody expected. And honestly, the coding world is still trying to figure out what just happened. We're talking about GPT 5.3 Codex-Spark, a model that writes code faster than you can read it, pushing over 1000 tokens per second while running on hardware that's not even made by NVIDIA. And the crazy part is, this dropped just 4 weeks after OpenAI announced their partnership with Cerebras. 4 weeks. Most companies spend months getting hardware working together, but OpenAI went from announcement to actual product in less than a month. So let's talk about it. Alright, so the first thing you need to understand is the speed. We are not talking about a small improvement here. GPT 5.3 Codex-Spark runs about 15 times faster than the regular GPT 5.3 Codex. That's not a typo. 15 times. When you ask it to build something, code appears on your screen faster than most developers can actually read it. Simon Wilson, who tracks AI releases closely, posted side-by-side demos showing Spark generating a pelican riding a bicycle way faster than the regular model. The rendering quality is lower, but that's not the point. The speed is what matters, because when a model responds this fast, you stay in flow state and keep moving without interruptions. Here is the thing though. This speed isn't just about OpenAI writing better software. The entire breakthrough sits on top of a completely different chip. We're talking about the Cerebras Wafer Scale Engine 3. And this thing is basically the opposite of everything NVIDIA builds. Instead of cutting a silicon wafer into hundreds of small chips, Cerebras keeps the entire wafer whole. One single chip. The WSE-3 measures 46,225 square millimeters, which makes it 57 times larger than NVIDIA's H100 GPU. It packs 4 trillion transistors, 900,000 AI-optimized cores, and 44 gigabytes of on-chip memory. That memory sits right next to the processing cores on the same piece of silicon. So data doesn't need to travel far. And when data doesn't travel far, you get 21 petabytes per second of memory bandwidth. That's basically the reason Spark can push tokens so fast. The data stays on the chip instead of bouncing between memory and processors like it does on GPU clusters. To be clear, this is OpenAI's first model running on non-NVIDIA hardware. That's a huge deal because NVIDIA basically owns the AI training and inference market right now. But OpenAI just showed everyone that when you need speed more than raw power, specialized chips can beat GPUs. And the timing matters because OpenAI signed a deal with Cerebras worth over $10 billion. That's not a test run. That's OpenAI betting serious money on a completely different hardware path. Now here is where it gets interesting. Speed is only half the story. OpenAI also rebuilt the entire way Spark talks to your computer. Most AI models use standard HTTP request, which means every time you send a message, there is overhead from opening connections, waiting for responses, and closing connections. OpenAI ditched all of that and switched to a persistent WebSocket connection. That single change cut round-trip overhead by 80%. They also rewrote parts of their inference stack and reduced per token overhead by 30% and time to first token by 50%. So when you hit enter, code starts appearing almost instantly. No loading snippets, no waiting, just immediate output. And these improvements aren't just for Spark. OpenAI said the WebSocket path will become the default for all their models soon, which means every OpenAI model is about to get faster. The model itself is smaller than GPT 5.3 Codex, which is why it's called Spark instead of the full version. Smaller models trade some reasoning power for speed, and Spark definitely makes that trade. OpenAI's official blog says Spark demonstrates strong performance on SWE-Bench Pro and Terminal Bench 2.0, two benchmarks that test how well AI agents solve real software engineering tasks. But they are very clear about the trade-off. Spark accomplishes tasks in a fraction of the time compared to GPT 5.3 Codex, but it doesn't match the full model's capability. The official language from OpenAI says Spark is optimized for fast inference and sits closer to GPT 5.3 Codex than GPT 5.1 Codex Mini in capability, though it doesn't match the full model. So, if you are working on something that needs deep reasoning across multiple files or complex system architecture, the regular Codex is still better. But if you are prototyping, defining interfaces, making quick edits, or iterating fast, Spark is the better choice because it keeps you in flow state. You type, it responds, you keep moving, no interruptions. One of the most interesting details is that Spark helped build itself. OpenAI said early versions of Spark were used to debug its own training process, manage deployment, and run evaluations. The team said they were blown away by how much Spark accelerated its own development. That's the kind of feedback loop that speeds up the AI process because now you are using AI to make AI better, and each version improves the next version faster. It's the same pattern we saw with AlphaGo learning from its own games, except now it's happening in coding models. In fairness, there are trade-offs everywhere. Spark only supports a 128,000 token context window, which is enough for most coding tasks, but smaller than the full codex. It's also text only at launch, so you can't upload screenshots or UI mockups. If you need vision support, you are stuck using the regular codex. And because Spark runs on specialized Cerebras hardware, it has separate rate limit during the research preview. OpenAI is still ramping up data center capacity, so access is limited to ChatGPT Pro users right now. API access is coming soon, but they haven't said when. One more technical point that matters, OpenAI confirmed that Spark doesn't reach their preparedness framework threshold for high capability in cybersecurity or biology. That means it's not as strong as security related code or tasks that need domain knowledge. The regular GPT 5.3 Codex is rated as high capability for cybersecurity, but Spark is not. So, if you are working on authentication systems, security patches, or anything where mistakes could create problems, you should use the full model instead of Spark. Alright, that's where we will wrap it up. One thing I'm curious about now is whether other companies will follow OpenAI into Cerebras hardware or if they will stick with NVIDIA. The speed advantage is real, but so are the trade-offs. Drop your thoughts below, make sure you're subscribed, hit the like button, and I will see you in the next one.